All right, 17C. We want to graph and label all the pertinent information. So the degree tells us a lot. If it's a degree of 3, it's a snake. If it's a degree of 4, it's a W or an M. If it's a degree of 2, it's the U, the parabola up and up or down. So in this case, my degree is 4. So what will be the shape? W or M. Now, since it is a leading coefficient of a positive number, that tells me also my end behavior. So what will be the end behavior then? Think of it as a quadratic. So rise on both sides. So now I know my end parabola, or my end W is a W. And then I would go out and try and maybe find the zeros of the function. So how do you find the zeros of the function? Which give you the x-intercepts. So you would set the function equal to 0 and then solve for x. So I can split up that x to the 4th into x squared and x squared. And then I say, what are the factors of 12 that add to -7? And that's -3 and -4. And then I could continue factoring the x squared minus 4 as the difference of squares, x minus 2, x plus 2. The x squared minus 3 is not nice to factor. So now we would use the zero product property and solve those for x. So I would add 3, and then I would square root, and I get plus or minus the square root of 3. With your calculator, what is the square root of 3 approximately?
1.7.
Okay. Over here, those quickly can be shown as 2 and -2. So I have my 4 x-intercepts. I have x-intercepts of 2, 0, -2, 0, 1.70, and -1.7, 0. I could also test for symmetry. See if there's symmetry about the x or the y-axes. And there's symmetry about the y-axes. To test for symmetry for the y-axes, if I throw a negative in for x to the 4th and a negative in for x squared, do I get my original function back? Yep. So I have, whoa, sorry, I kind of went far up there. I have y-axis symmetry, because if I plug in f of negative x into the function, negative x to the 4th plus negative 7x squared, that was a plus 12, I get the original function back. So -7? -7. Anyways, so this is should be a negative here, which is still fine. So that's telling me I have y-axis symmetry, so whatever happens on the right of the y-axis has to happen on the left of the y-axis. So let's go ahead and start graphing out some of the things that we have. I'll space this, maybe we'll call this 1 and 2, space it out a little bit, and then -1 and -2. And identify your 4 x-intercepts, 2, 0, -2, 0, and then I have another one at 1.7, which is, here's one about here maybe, pretty scrunched up still, but, and then 1.7, 0. Now the end behavior, we said, opens up on the right and on the left. So those farthest out x-intercepts are going to be rising and rising. And then we have the shape of a W. So then you may want to just try something like evaluate the function for 0, and then just what happens in between there to get that shape.
Wait, so there's a curve between the 2 and the 1, like the walk.
So it probably does something maybe like that, or maybe like this, one of those two. And if you'd want to just try something in between there, yeah. And you would just try a couple points in there. Or maybe start with 0 and -1. And you plug it in for x, yeah. Is that okay if I stop there just so we can get to some other questions? So that's a lot of it, but that's kind of the start of it, where you identify the degree, the shape, the end behavior, the zeros of the function, which are the x-intercepts, what the symmetry is, and then find a few additional points. And that's for your snakes and your W's and M's. What else do you have for me? One of our problems? Sure.